The inkJet printer is such a genius invention, but it's a pity that this device is still monopolized every day. If we enlarge the printed photo, we will see that the photo is made up of previous ink droplets. Not only that, the printer can print with only 4 kinds of ink. What is the magical principle behind this? The core lies in the nozzle. There are a large number of nozzles distributed on it, each thinner than a hair. The nozzle is designed to be wide at the top and narrow at the bottom, which creates negative pressure. Once printing starts, the heating resistor above will heat the temperature to 100 degrees in 0.000001 seconds, and the high temperature will cause the nearby ink to form bubbles. These act as pistons and push out the ink below. Due to the viscosity of the ejected ink, it will form a main droplet and a trailing droplet. They fall at a speed of 10 meters per second. The nozzle is 1 millimeter away from the paper, so it only takes 1/10,000th of a second to reach it, and it is absorbed by the paper in a very short time. The nozzle is connected to the printer through a soft tube. A non-inflatable motor drives the belt and pulley to move the nozzle, and a shaft stepper is added to move the paper. This is the basic structure of the printer. So how does one use 4 inks to print colorful photos? You might think of using a mix of red, green, and blue. Let's do a small experiment first. If you use a red and green flashlight to add and mix, you will get yellow. But if you mix red and green ink, you will get a very turbid yellow. In fact, this is the difference between additive color mixing and subtractive color mixing. For self-illuminating shades, mixing the 2 colors increases the brightness, but the ink itself does not emit light. We can see the ink because light hits the ink and then reflects into the human eye. This process will filter out part of the light. For a better understanding, let's magnify the ink droplets to a microscopic perspective. If the green molecules in the lower layer want to reflect green light, they must penetrate the green and red molecules in the upper layer. But this process will be blocked by the red molecules, producing black in this area. Similarly, the red molecules in the lower layer will also be blocked by the green molecules in the upper layer, and the resulting black color will cause a yellow change. To give another popular example, the gray hair we see with the naked eye is actually the result of a mixture of white and black hair. So obviously, the 3 primary colors of red, green, and blue cannot be used directly in the printer. The solution is easy. Just replace red, green, and blue with their complementary colors: cyan, magenta, and yellow. When the nozzle releases a drop of cyan ink and then quickly releases a drop of yellow ink, the 2 mix together to create an intoxicating green color. The diameter of the mixed droplet is only 0.05 millimeters, and a variety of colors can be obtained in this way. So what should you do if you want a lighter green? In fact, you can get a lighter green by increasing the spacing, which will make it appear darker, but the spacing is always limited. What if you want a darker green? This is when black ink comes in handy. Mixing black into green ink will result in dark green. The more black you mix in, the darker the green will be. So as long as you use the 4 colors of cyan, magenta, yellow, and black, you can print up to millions of colors. And a photo of A4 size can even have a motorcycle. We have to admire the wisdom of human beings. Like and follow for more informative 3D videos.